For maintenance personnel on staff, this is a quick review of the boiler system, and as part of that, there's 2 boilers. There's a master slave, duty standby, one backs up another, okay? As far as working with the boilers or dealing with any issues with the boilers, because they are a gas appliance, it's necessary to have a licensed contractor with both their TSSA license and their gas fitters license, and they have to have familiarity with the boiler. So we can't get into the inner workings in terms of maintenance, troubleshooting, etc., because that needs to be done by qualified personnel. But for on-site maintenance staff, the boilers do come equipped with a display, all right? And that display will show the status of the boiler. In addition to the status of the boiler off the display, there's a rocker switch on each boiler, either on or off. You can see this one's on for display purposes and this one's off right now, okay? When the boiler is running, the display will indicate that it's in a run mode. When you first show up to this display, it will be basically blank. You touch the display and it comes up, and then you press in the middle of the display, there's a little blue control module. You press that, and then your home screen comes up with all the necessary parameters, okay? If there's a fault that will show up, it'll be coming across here where you currently see history in blue. That will change color and there will be a fault registered. So with the fault registered, what you're doing is basically trying to determine what the next step is as a maintenance personnel. You refer to the owner's manual. The owner's manual will indicate what that fault represents. And here's a copy of an owner's manual here for reference. And that fault will tell you what can be done to correct it. If it's something as simple as resetting the control, you can reset or clear the fault on the screen by touching the red or yellow fault indicator, and then another screen will come up and you can clear it. If the boiler doesn't reset itself, then you will just kill the power to the boilers, allow the boiler and then press it back on again, allow the boiler to reset, reconfigure. There's an integration period between the control and the master control for that to happen. At that point, it will come back online and you press the blue control button in the center, and it will go back to this home screen, and you'll be able to see it go through its ignition try, okay? As far as the operation of the boiler, there's various safeties. This safety here is a low water is a flow switch, okay? This flow switch is on each of the 2 boilers. If for any reason the boiler circulators are not functioning or fail to come on a call for heat, then that flow switch will not register flow, and it will not allow the boiler to go through its pre-ignition cycle. In addition to that flow switch, there's a secondary safety control, which is a little further over below the pump, and that is called a low water cutoff, a probe low water cutoff. Low water cutoff proves that we have fluid in the system and or that the low water cutoff is not malfunctioned. The green light on the low water cutoff indicates that it's showing that we have appropriate flow and the sensor isn't dirty, and it will allow the boiler, along with the flow switch, to prove out on the control and allow the boiler to go through an ignition process. This boiler is currently running as both those controls are satisfied, okay? So externally to the boiler, it could be a pump issue if you have a problem. It could be a low water cutoff issue or a flow switch issue, and or the pump starter is failing to call the pump on. The pump starter is interlocked with the boiler, so on a call for heat based on sensors, which are installed both in the boiler, each of the boilers, and externally to the control boilers up in the piping. There's a supply sensor on the secondary side of this device, and then there's an outdoor sensor outside Between the two sensors, they monitor, okay, this is the temperature we have outside. This is the calculated temperature we want going out to the building for the fan coils to heat the building. And it will change that within a pre-programmed variance. Because it's fan coils, we don't want the water temperature getting too cold, so the air temperature doesn't get too cold. All right, coming off the fan coils. So it will work between a lower and an upper temperature based on outside air temperature, and tell the boilers to fire and come on and go off. If one boiler can't keep up, and or if that boiler fails and locks out, the secondary boiler will come online in its place as a replacement to the one boiler that's offline, or a supplemental input for quicker recovery for the other main boiler that's also running. Okay? And they will, they have what's called lead lag function, so they get equal wear time. So every so many hours, this boiler will become backup, this boiler will become first stage, and they will run, I think it's factory programmed every 72 hours. Okay. Other than that, there's really, if there's faults that you can't address by strictly resetting on the face of the control or resetting the power to the device or to the boiler, then that's when you call in your outside maintenance contractor, a service contractor with all the requirements. What we have here is the primary and backup main heating circulation pumps for the building. These pumps work together to provide the hot water distribution throughout the building to heat all the fan coils. All the fan coils out in the building have both two-way and three-way control valves. So what that means is the system pressure out in the building that's sensed by these pumps goes up and goes down. So these pumps are each equipped with self-sensing variable frequency drives. These drives are designed so that they know and they understand the relationship between the motor horsepower and its amp draw and the system pressures. They change, so the VFDs respond to that change, so that we'll always have what would be considered constant pressure out into the system. So as valves close, pressure tends to go up, so the drives respond, slow the pump down to match and maintain pressure down a system curve. Okay. In terms of control, in terms of maintenance of these products and understanding them, they're what's called a vertical inline pump. The motor is above the pump end. They're closed coupled, so there's no coupling, but the motor shaft is the pump shaft, and it's attached to the impeller inside the pump as it spins. There is a seal kit between the motor end in the cover plate and the pump that separates the water from the ambient air around the pump. That seal basically is a stationary surface and a rotating surface, and they spin at a high rate of speed. Whatever the speed of the pump is the rate of RPM on the seal. The intent of the seal is to allow for that movement between the two faces and RPM, but not allow leakage of water. What can happen over time is that the seal can wear. It could be, it's dependent on the ongoing maintenance and chemical treatment and maintenance of this fluid in the system. And it also, the initial seal leak will basically take place. It can be premature, or it can be way down the road. It depends on, during the cleaning and flushing process, how much debris in the piping while it was being flushed and cleaned got across and between the two seal surfaces. Because the seal surfaces are constantly flushed with a seal flush line, which I don't know if you can see it, but between the discharge side of the pump, there's a small seal flush line that goes into the top motor cover, or sorry, the pump cover, and it allows a small amount of fluid to be constantly flushed across the seal surfaces. And that helps get any debris off the seal faces. Right? Okay. So in addition to that, if there is, in the event of a seal the seal, it starts to fail, starts to wear, surfaces get rough, whatever it may be, you will start to see fluid leak out of the top of the pump. The seal is inside of here, so you will see it come out over the cover plate, which you can kind of see down under here. And again, it will drip down over the sides of the pump and onto the floor. If you happen to see that take place, that's time to call, again, a service contractor, whoever you're working with. They will obtain a replacement seal based on the pump ID label, okay? And the pump ID label, in this case, is located in two places, on top of the drive and down on the side of the pump. I have to walk across the screen here, a second. Yeah, each pump has an aluminum plate fixed here. Should never be removed because that's all the vital information on the pump. Okay, and that will give you the manufacturer's order number and the pump details so that you can allocate through your local service dealer and the wholesaler contractor the required seal kit to replace. Seal kit comes with a casing gasket, two-piece seal, shaft sleeve replacement, as well as shaft sleeve gasket. Comes in a little box, and then the contractor would come in, isolate on the suction side, and isolate here on the discharge side because this valve can be closed. And then you would allow the system to cool, drain down, change the seal. And the seal gets changed by removing the radial bolts around the base of the motor pump cover bracket, lifting, and then tilting on its side, getting access to the impeller, spinning the impeller bolt off, pulling the impeller, and then changing the seal. Okay, so it's a bit of work involved. So again, it's a contractor deal, right? So each pump also has what we refer to as a suction diffuser. That's this here. It allows you to go from a pipe size, which in this case might be, was it 4-inch? 3-inch, down to the pump inlet, which could be a 2.5 or a 2 or maybe a 3. But more importantly, this device is meant to maintain what's known as laminar or nice straight flow into the inlet of the pump when you have a tight turn like this. It also has a strainer in it, a system strainer, that if pump performance is changing or you're getting some noise out of the pump, it's cavitating, it could be that the strainer has gotten loaded up with debris and needs to be removed and cleaned and then put back in. You can remove again by isolating in and out, allowing the system to cool, drain the valve. There is a drain right here. And taking these radial bolts off, removing the plate, backing out the strainer, flushing it, putting it back together, just like you took it apart, okay? And in this case, it's a rubber gasket, so it's reusable. So on every one of the vertical inline pumps on the job, for both these two heating and the two chilled water over there, there's also a multi-purpose valve. It performs a few functions. One, it's a check valve. So if this pump's running, we want the check valve it will swing open because we have flow, but rather than push it back into this pump, which is off, there's a check valve that won't allow reverse flow, so all the flow goes out to the system. So one is check. Two is it's also a balancing valve, but that's kind of redundant here because we have self-balancing pumps based on pressure response in the system. So in this case, the balancing valve is probably not even used. It's probably fully open. Okay. So the third function of the valve is its positive shutoff. So this particular bolt here, you spin it, closes the valve, locks it down for when you want to do any isolation purposes for maintenance of seal replacement, cleaning of the strainer, so forth. Okay. And that's basically the operation of the pumps. These drives on each of the pumps, they basically are reading and reacting to system pressure based on motor amp, as I explained earlier, and they're speeding up and slowing down one pump. The way it's set up to work is that there's one pump that runs, and that's your duty pump. The other pump is meant to be a standby. This runs, maintains, and it's designed to maintain the flow required in all conditions for the heating system. As time clocks off on this drive, it has an internal clock as well that's in the programming embedded. It says, okay, I'm going to shut myself off and we're going to turn this one on. Okay, so it's called lead lag duty standby, and that rotates back and forth, so both the pumps, motors, and wet ends get equal runtime and wear, as do the seals. And more importantly, the seal doesn't sit for an elongated period of time, so you don't get lubrication. It can dry out and stick. Next time you do happen to turn it on, say if we're not doing it automatically, in a year or 6 months, that seal could be stuck to the point where when that motor turns on, it can actually cause that seal to crack. One of the surfaces can get pulled apart. Now you have a leak, right? So if you hear vibration or feel vibration or any odd noise coming out of the motor or the pump, that's time to get your service maintenance contractor in to take a look at it, assess what needs to be done. And they'll typically consult us as the manufacturer's rep, and we will in turn assist them in what the repair is. And we do have service dealers, pump houses throughout Ontario that work closely with us. Yeah. Okay, and that's it for the vertical inline pumps with drives and their accessories. This is what's known as an expansion tank. Every hydronic and every chilled water system, and this will hold true for all the tanks in this mechanical room, so we'll just focus on this one. Every system, whether it's chilled water, hydronic, or glycol, radiant inflow, as system fluid temperatures go up and go down in an enclosed system. What I mean by enclosed is it's all in piping, there's nowhere for it to go. Water and or glycol water tend to expand and contract. So if it expands, you need a place for it to go. So as you heat the water and the boilers are running and you bring the system temperature up, the water will expand. So the idea behind an expansion tank is there's a big rubber, for lack of a better word, bladder or balloon inside. And the system fluid is tied into it. This blue aquarized pipe is the connection to the system back to the expansion tank. So as that water pressure goes up, it needs to go somewhere because it's expanding. It goes into the bladder in the tank, and on the other side of the bladder, there's an air charge valve on the top of the tank, and the tank comes pre-charged, and then it gets adjusted for site conditions, i.e. how high the building is and how high a water column is above it. It will push the bladder. So when the system's cold and you first start it up, it will push the bladder so the bladder is pretty much empty, and all the system fluid is out in the system. As the water heats up, starts to expand, that starts pushing back and fills up the bladder. And that's what's known as acceptance volume. Okay, it accepts that fluid, fills the bladder, but maintains a closed system and then pushes it back as the system cools. And that's a constant thing. It'll move up and down over time as it heats up and cools down, okay? And that goes for all the tanks in the system. If you have an issue with the tank, i.e., and this is really the only issue that will happen with these tanks, you get a rupture or tear or a leak in the bladder. What happens is the system fluid goes in to the secondary side where the air is, pushes the air out of the tank, and that air, now we have no cushion and no bladder anymore. So the next time the system heats up, fluid starts to expand. Because there is, if you want to focus over here, because there's a pressure reducing fill valve tied to the street water, that and then through a backflow preventer, through the PRV, what will happen is it senses a drop in pressure, that fire valve over there, and as it senses a drop in pressure, it will open up and allow more water into the system to fill this tank and replace that air that's no longer in there because the bladder's ruptured and it's been pushed out in the system and removed by the air eliminating equipment. So you'll start to see situations where the boiler PRVs could start blowing off because the pressure, there's no place for the water to go. There's no place for the water to expand. So it starts blowing off on pressure reliefs elsewhere. And that's an indicator that you have a rupture in your bladder. The other indicator is you can take off the valve cap and you just press it's kind of like your bicycle tire tube. You have a Schrader valve. You just press the little valve in the middle. If it squirts water, then you know you have a ruptured bladder, and that means it's time to either replace the tank in its entirety and or replace the bladder. And again, there's a rating plate here with all the information on what the tank is and what the rating is. And interestingly enough, no, it's not there, it's gone, but you'll see on some of our Taco pressure vessels, there's a little green near field chip. It's hidden in a plastic and it's embedded, it's stuck to the device. Some of our tanks are coming out with that now. You can actually download an app from Taco or from Apple from Apple or Android, and either one of those will allow you to use that app, so you can come up and hold your phone near field to that green little tab, and it will give you all the information, including the project number by the manufacturer, the model of the device, the factory pre-charge, the subittals, the IOMs, everything, right onto your phone. Equipment we have here is system/glycol feeder. It's automatic. How it works is there's a built-in pressure device in here that senses the pressure in the system. And what it's used for is when we have systems that have special fluids in them, such as glycol, where we want to maintain a mixture of water and glycol at a certain percentage, the tank gets filled through the fill port with pre-mixed glycol. In this case, it's probably either 40 or 50% glycol and water. So this way, if our system needs to have some fluid added to it, essentially this will sense the pressure drop, add the fluid because there's a pump in here, pressurize the system back up to the design pressure that this valve is set at. And it will automatically do that. There is a float switch in the tank, so when the tank gets down very low, and the float switch changes from it's an angle float switch, so if the float switch changes from an angle and starts to drop, it will open its contact and will not allow the unit to run anymore. And in this case, they've incorporated a panel that's wired to the device, and the alarm contacts on the device that say, hey, our tank is empty. We don't want our pump running anymore. We can't pressurize the system anymore. So it will activate the alarm, okay? And the alarm light will come on and the green status light will go off. So I think we can mimic this here just strictly by hitting the test button. Is that correct? Okay, there's your alarm. And that will indicate it's time to come down and check things out. I'm not sure if you're going to be doing and adding pre-mixed glycol. I see a glycol pail there. Is that glycol? Okay, so that pre-mixed glycol can get added into the system. If the condition continues and you keep emptying the tank, it's an indicator that you have a leak somewhere in the system and you need to address it. My recommendation is, I know Keith and Mackenzie Mechanical will leave this with a level in it that they're comfortable with, so that now that the system's been running for a period of time and most of the air is out of the system and has been replaced with a pre-mixed water and glycol, that they will just, they'll leave a certain level in here, and if it empties itself out and that alarm goes off, that's an indicator you have a leak. But we know with the chances are in this system on the this is the chiller side, right? On the chiller side, there's probably not going to be a leak. You will hear it run a little bit for a few seconds or maybe a minute, for short bursts as air continues to bubble out and get it removed out of the system and replaced with the premixed glycol and water. Okay? So that's about it on this. In terms of maintenance, there really isn't any maintenance. If you're not doing premixed glycol and you're doing water and glycol, there is a function here where you can put your water in, and there's gradients on the tank, okay? So you can put equal portions of 100% water and 100% glycol, top it up to whatever level, and then you should really mix it, okay? So because they're two separate fluids, they won't necessarily mix. So there is a mix feature just strictly by turning this valve 90 degrees. It allows it to pump back into itself and mix. You can see the agitation on the tank in the water, and the glycol is mixing. Then you close it back up, and hopefully it will shut off and pressurize. That's what the pump basically runs like. You can hear it. There you go. You can hear the pump working harder. The pumps on these are designed, they're not really a high flow pump. They're a diaphragm pump, so they're meant to fill very slowly at a limited gallon per minute. So it takes time. There you go. So we're recharged. The device we're going to look at here now is what's known as a air separator. In this case, it's a higher end micro air separator. And the purpose of this device is all water glycol contains air. And when you put that water glycol into a closed system, and as you heat it and cool it, and expands and contracts, you have to try and remove the air from the system. And the reason we need to remove the air from the system is because it can create issues with the system. We won't bother getting into that, but this device allows for in this case, the water glycol mixture to run into the tank. There is in the tank a large, what's known as a stainless steel pile ring bed, and how it removes the air, it's based on coalescence and accumulation of air on all these pile rings. The air accumulates, breaks away, goes to the top of the tank. At the top of the tank, you can't really see it visually from here. There is what's known as a high capacity commercial conical air vent, and that automatic air vent senses when the air builds up in the top of the tank. There's a float that drops, opens the valve, allows the air to bleed out. As the air is displaced by the water going back up to the tank, it then closes that float and the valve. All right? There is potential for that valve and float mechanism to get plugged and malfunction, either shut or open. Shut means you get no air removal, so you're going to have air in the system which isn't healthy for the system, or you're going to have removal all the time, which means you'll have a visible leak off the top of the air valve, and it will need to be inspected, replaced, or repaired, or cleaned. Okay? On the bottom there is a drain here that can be used to remove any debris that accumulates in the tank as well. Okay? Other than that, there's no real maintenance of the tank. It's just an ASME pressure vessel, and it's designed to allow the flow to slow down in a bigger chamber, and the pile ring bed to accumulate the air and allow it to break away, rise up. It's one of the most effective air eliminating devices on the market today. This particular piece of equipment is known as a gasketed plate frame heat exchanger. Underneath all this insulation, which is in place to stop it from sweating because it is chilled water for cooling the building. There's a glycol loop to a cooling tower, which has got the glycol in it, and then there's the chilled water on the building side, which is just 100% water. It's designed to allow transference of the chilled water, cooler glycol water from the tower into the chilled water. Okay, so it's known as a heat exchanger, and there's really no maintenance to this. It's been factory assembled and pressurized and to tolerances. It's an ASME pressure vessel, and essentially the only thing that can cause issue is you could get a leak down the road. between a plate and a gasket. And if that's the case, the insulation would have to be removed. A service contractor that's familiar with the product and has the tools to open it up, replace the gasket. Down the road, in like years down the road, it is potential, there is possibility to need to open the entire heat exchanger up and clean every plate and replace the gasket set, which is called a complete refit. And that can happen as system gets older, there's more debris, it has to do with maintenance, you're getting dirt in there, entrainment of untreated fluid precipitates out on the plates, so its capacity drops. And that's about it. There's not much to it, no moving parts. Essentially what we have here are modulating condensing water heaters. There's two of them. They basically sense the temperature that's in the tank. They're set to maintain basically approximately 140 degrees. They are condensing and they use gas to heat. In terms of maintenance, it's something again that needs to be looked after by an authorized TSSA certified contractor, maintenance or installing. There is on here one item that says corrosion protection, the green light. What that is each tank is equipped with electronic cathodic protection. And what it is, it's an automatic cathodic anode rod that there's a small millivoltage that goes across and protects and works like an anode rod. If this ever turns red, that means that it's not working. That means you do not have protection from excessive corrosion and corrosion of the tank through electrolysis. So it's necessary to shut the heater off and get this addressed. Okay. Other than that, on the main display, it tells you when it's running. Right now, it's the store hold operating at 23% of its capacity, and it's working, and it's got a current temperature in the tank of 135. It will probably fire up to bring it, its store hold down. It will fire up shortly as that temperature drops. And if the temperature rises closer to set point, it modulates down and then shuts off. And that's essentially it. It does have a condensate drain connection similar to the boilers, and that condensate connection is hooked up to a condensate neutralizer, which makes sure that the water that's coming out of the condensate is neutralized, it's not acidic, okay? If that condensate neutralizer becomes plugged, then it needs to be addressed because it can back up into the exhaust connection and cause the heater to shut down. That will show up here as a fault as well, okay? And the condensate neutralizer drain, essentially, the media does wear out over time and you do need to replace it, and the only way you can determine that is either by a maintenance contractor or on-staff maintenance that has pH strips. They can check the condensate that's going down the floor drain from the heater, and that will tell you if it's pH neutral or not. If it's not, then you need to replace the condensate neutralizer media, which can be done quite simply by in-house staff or by a service dealer. Right. That's it. There is a pressure relief on this as well. If pressure goes above the rated PSI and or temperature goes above the rated temperature, this will start to weep. It will blow off on the floor, and the next time maintenance comes in to look over everything, they will see that on the floor, know that there's a potential high temperature or high pressure issue with the heater. What we have here is we're in a typical suite, and every suite in the complex has basically a ceiling mounted horizontal fan coil package. It does both cooling with a cooling coil and heating with a heating coil, and there's a fan that speeds up and slows down. All of that is controlled and determined by a thermostat in each suite. Okay, when the thermostat's calling for heating, the heating zone valve opens, allows flow from the central boiler loop to provide heat, and the fan is also turned on. If it's not running in low speed constant, it goes up to high speed for heating. And then same goes for cooling. If the thermostat calls for cooling, the zone valve for the cooling coil, chilled water coil, is opened and allows flow for chilled water to cool the suite. All controlled by the thermostat. In terms of maintenance by building staff, the only thing really that they need to get involved in is I would check to see how quickly the filter loads, but there is a return air grill right here. There's a little screw that you nylon screw that you back off, and on the back side of this return air grill is a filter media. And that filter media stops any debris from going through the fan coil, loading up on the fan blades and or the coils. And it keeps things a little cleaner, less dusty in the suite. That will need replacing. Typical replacement under normal circumstances is usually quarterly, but with these type of buildings and multi-suite applications, that could be annually, if not at all, because there's very little debris or dirt, because everything that's coming into the building with makeup air is filtered, okay? And in terms of maintenance, other than that, there's really nothing to worry about. If you get a tenant or a resident, sorry, that is having issues, they're not getting heating or cooling, chances are it's either thermostat setup, or perhaps a fan is malfunctioned, or one of the two zone valves is malfunctioned and locked and not opening. And that would require a service mechanic to come in and address.